Dr. Janice Lough describes herself as an environmental historian.
I enjoyed looking and have worked over the years on historical climate records, and most specifically the records contained in massive coral skeletons.
Many coral species have growth rings, similar to those found in trees. The rings allow paleoclimate scientists, such as Dr. Lough, to reconstruct the past well beyond what we know from modern observations.
And all those records point to just how unusual the current climate changes are in terms of the past several hundred years. The system really is starting to change, and that's evident in these natural archives.
If you take a slice from a long coral core and put it under ultraviolet light, you'll see these bright luminescent lines. In this example, the lines relate to the flow of fresh water into the Great Barrier Reef.
We're in Townsville at the moment, and to the south of us, there's a great river called the Burdekin River. At some times of the year, in winter, you can walk across the riverbed. In other years, extreme wet years, there are tremendous amounts of fresh water that actually go out onto the reef. These luminescent records in the corals allow us to reconstruct the river flows, going back into the 1600s.
And that reveals that flood years are happening more frequently and becoming far more extreme.
Now, this corroborates with the theory about climate change. A warmer atmosphere can hold more moisture. As we've seen over the past few years, you're likely to get bigger flood events now than you did, say, 50 or 100 years ago. These corals provide corroborating evidence that that is, in fact, actually happening.
Coral reefs can only survive in a very narrow temperature range.
If it gets too extreme, the temperatures can lead to something called coral bleaching.
Something that now happens regularly along the Great Barrier Reef.
Reefs of the future are probably not going to disappear entirely, but they're going to look much simpler and provide less habitat, food sources for the many other reef-associated organisms.
Dr. Lough has spent much of her career at the Australian Institute of Marine Science, but her work has helped climate modelling around the world, including in the Pacific Islands.
We ended up explaining our results specifically to the fisheries managers from the Pacific Islands, so they got direct feedback about information that was relevant to their sector.
Her lifetime of work assessing the nature and consequences of climate change has seen Dr. Lough elected a Fellow of the Australian Academy of Science.